All right, welcome back. This is example 3 for Math 220 from today. And so here we look at the denominator and we notice that it's already in factored form. So actually we don't have much to do there. But what is new is to notice that here we have a square and another square here. So the degree of the denominator is 4 and the degree of this numerator is 2. So we have to take that into account, and you'll see how that shows up in the factored forms. Also note that this x to the squared means that this is x minus 2 times x minus 2. And so this is a repeated root, so we have to take care of that case in our factorization. Okay, so let's go ahead and jump into how does this square affect that, and then also notice that this is irreducible. Is irreducible over the real numbers. In other words, this doesn't factor. It doesn't factor over the real numbers. Okay, so we can't. This is it's in its lowest reduced factored form. Okay, so let's take a look at how each of these individually affect the form of the factoring, and these are the two. Either one of them is typically very confusing, and then the fact that they're together just makes this even more of a delicious problem. So let's dive into it and see what we get. Okay, so we have x minus 4 squared, x squared plus 3. Okay, so the first one, notice that, like I said here, this is x minus 2 and x minus 2. So since this is a linear factor on its own, each one individually is a linear factor, if we take into account that one first, we have an x minus, oh, it's a 4. Oh, that's a 4. That's a 4. That was what was bothering me. It's an x minus 4 squared. So it's a 2 of those. That was my bad. So this is an x minus 4. Okay, so this is the linear factor, and that takes care of this first one. So plus b. But notice that if I multiply through by x minus 4, it's going to cancel out here, but I still have an extra factor that I can't get rid of. I can't clear it out because it's going to take care of both of them. So in order to eliminate that, I'm going to repeat that. And so whenever you have a repeated factor or a multiplicity of greater than 1, there are 2 of them here, you're just going to have as many extra factors taking in. And again, it's because if I clear this out by multiplying by x minus 4, just a linear term, it's going to cancel both of those out, and I'm going to be left with an extra factor. So this is taking into account that there is a multiplicity here. Okay, so whenever there's a perfectly factored trinomial, whatever that power is here is how many linear roots you're going to have. So this was at 3, for example. I'd have an x minus 4 and x minus 4 squared plus a c over x minus 4 cubed, quantity cubed. Okay, all right, plus, and now let's look at this term here. Okay, so this is a square term that's irreducible, which means that I want my numerator, since the denominator is on this factor, is x squared plus 3. Remember, I want the difference to always be 1, and so that means that in this case, I'm going to have a linear factor upstairs. So I have a cx plus d to represent the linear factor, and so that this difference is 1, this difference is 1, this difference is 1. Okay. All right, and so now that's in the factor form, and that's how we have, in this case, where the degree of the numerator was only 2 and the degree of the denominator was 4. This is what allows us to separate it out, is that now in this form, each of these corresponding factors only have a difference of 1 in the factored form of the numerator and the denominator. Okay, all right, so we're going to multiply everything through by this term like we did previously. And so it's going to give us an x squared minus 29x plus 5 is equal to a. And I'm multiplying by this whole thing, so I'm going to be left here with an x minus 4 term, because only one of the factors cancels, and then x squared plus 3 plus b. And here now both of the x minus 4 quantity squares are going to cancel, so I'm just left with a x squared plus 3 term, and then plus, and now here this is going to cancel, so I'm left with cx plus d times an x minus 4 squared. All right. Okay, so now we're going to have to do some algebra and clean it up, and this is when it gets really messy. So just to be clear here, notice that you have an x minus 4 because that's what I'm multiplying everything through by. So the x squared plus 3 term cancels, but I have an x minus 4 quantity squared term there. Okay? All right, so I'm going to multiply everything out and then combine like terms. So I'm going to pause this and write that out for us. All right, after careful manipulations and multiplying everything throughout, we have them termwise. So you can see, for example, the x cubed for the coefficients for the x cubed come from multiplying a times a, or x times x squared, which gives us the a here. Likewise, the c comes from this x times multiplying the x minus 4 quantity squared feature out. You're going to get an x times an x squared, which gives us then the c. Okay, likewise, the coefficients for x squared are negative 4a plus b minus 8c plus d. The coefficients for x are 8a plus 16c minus 8d, and the coefficients for should be a minus 12 a plus 3b plus 16d for the constant terms. It's a minus 12. Okay, so now we're going to use this and we're going to equate coefficients. So in this regard, notice that there are no x cubes on the left hand side. So it's counting down the x cubes. There's 0 x cubes on this side, and then there's an a plus c on the right hand side. If we look at the x squared terms, there's a 1 on the left hand side, and there is a minus 4a plus b minus 8c plus d on the right hand side. That's these coefficients. And x coefficients, there is a negative 29 on the left hand side, and that's equal to 3a plus 16c minus 8d on the right hand side. So that's these coefficients. And then the constant terms, we have a 5 on the left hand side, and we have a minus 12a plus 3b plus 16d. Okay, so this system of equations is what we have to solve now. Notice here that we have a is equal to negative c, and we have 1, 2, 3, 4 unknowns and 4 equations. So this system is solvable. I put this into GeoGebra and solved, and I'll show that to you in a minute, but this is a equals 1, the result is b equals negative 5, c equals negative 1, and d equals 2, okay? Which then allows us to rewrite all of this in the form of the integral. So a is 1 over x minus 4 minus 5 over x minus 4 squared, and then plus, let's see, we have 2 minus x over x squared plus 3, which you can write a little bit more simply by writing x minus 4 minus 5 over x minus 4 quantities squared plus 2 over x squared plus 3 minus x over x squared plus 3. Okay, so this and this and this, these are all u subs. So here you're just going to let u equal x minus 4, u equal x minus 4. Here you're going to let u equal x squared plus 3. And this one is going to be a tangent, so you're going to let u, or no, you're going to let x equal the square root of 3 tangent, let's say theta. Okay, and so each of these has a different substitution that you'll need to make in order to integrate them. But once you plug them in and integrate them, let's go ahead and do that now, and then we'll come back and show the tools I used, the technology tools that I used for the simplification here and the solving there. Okay? All right, so integrating the first one, du over u, this is for the a term. This is going to give you the natural log of u, which is going to equal the natural log of the value of x minus 4. Okay, so that's the first term. Then we had minus the integral of 5 u squared, which I can simplify a little bit more as negative 5 the integral of u to the negative 2 du, which adding 1 and dividing by it, we're going to get a positive 5u to the negative 1. And then finally we get 5, bringing the u down and resubstituting, I get x minus 4 is the result of this integral. And then what do we have next? We have, I'll do the last one, so minus x over x squared plus 3 dx. We let u equal x squared plus, so this is the u down here, and then we get a 1/2 du out of that. Okay, and so factoring out the 1/2 and becomes a negative, get the natural log of u here, and so finally get negative natural log, and our u here was x squared plus 3. So this term is never negative, so the absolute values aren't necessary. And then finally we have the integral of 2 over x squared plus 3 dx. So here, letting x equal the square root of 3 tangent theta, dx is going to equal the square root of 3 secant squared theta d theta. So plugging those in, you're going to get the integral of 2 square root of 3 secant squared theta d theta over, this is going to be squared, so this is going to be 3 tangent squared theta plus 3. Factoring out that 3, you're going to get 2/3. Usually 2 square roots of 3 over 3. So factoring out the constants there. Integral, you get secant squared theta over, this is tangent squared plus 1, which is secant squared theta. So these reduce to 1 d theta. So this is just the integral of 2 square roots of 3 over 3 theta. And now coming back here to this, to solve this for theta, we're going to get x over the square root of 3 tangent inverse is going to equal theta. So this final term is 2 square roots of 3 over 3 and then theta was tangent inverse or arctangent x over the square root of 3. Okay, so that's what theta is equal to, or the whole integrand is equal to. All right, so putting everything finally together, the very last result then, of course, is natural log absolute value of x minus 4 plus 5 over x minus 4 plus, or minus 1/2 natural log of x squared plus 3 plus 2 square roots of 3 over 3 arctangent of x over the square root of 3. And so there is the final integrand. And again, the key here is to note that you have two special cases which made this particularly ugly. The first one, of course, is the repeated root, and so you have to take care of the fact that these both can't be x minus 4s, because when I multiply through by x minus 4, that cancels everything out. And then since this is irreducible, you're going to get a linear term in the numerator for that. Okay? All right, I hope that was helpful, and I'll see you in the next video.